Good morning, students. Last time we have spoken about nothing but we have completed the what we call as the periodic functions with respect to halogens, and we have discussed all the different what I can call as the behaviors, that is their oxidizing nature, and we have also spoken about the oxidation states and the anomalous behavior of fluorine. Now today onwards we will start with the next part over there, where in the next part what we are going to talk is mainly is about nothing but the compounds of halogens. The first one, chlorine, Cl2 molecule formed by pp axial overlap. Now there are certain ores of fluorine which are not given over here. I want everybody please write it down. This will help us for the JE and the NEET part. Keep a book and keep a book or something. Write down what I'm saying. Some of the ores of chlorine. One is rock salt. We all know that's NaCl. Second is carnallite, CARNALITE. That's KCl dot MgCl2 dot 6 moles of water. That's carnallite. Next we have sylvine, SYLVINE. Sylvine is nothing but KCl, potassium chloride. That's basically the trade name of it, sylvine. And last we have an ore of chlorine, what we call as horn silver. Horn silver is what we call as AgCl, silver chloride. Okay. So these are some of the ores. Now going next, people, chlorine we all know. Chlorine, the word chlorus means it's basically a greenish yellow gas what we have. That's the meaning over here, what's given this part. Okay, the meaning of the word, that's chlorus, which means it is greenish yellow. Now first we have the preparations over here of chlorine, where it is from manganese dioxide, that's MnO2. That's also used if you people, when we do electrochemistry, we're going to have, in case of a dry cell, MnO2 is used over there. All right, it's a depolarizer. What is used there? MnO2, Mn ka oxidation state is nothing but +4. So when it reacts with chlorine, MnO2 becomes MnCl2. Matlab +4 is reduced to +2. And HCl chloride was -1. It becomes chlorine. So chloride is oxidized to chlorine there. That's the part. Okay, that's one. So MnO2 is reduced, and we will say HCl will get oxidized to chlorine. That's one. We can also use it say as a mixture of common salt, that's NaCl, and Kong sulfuric acid can also be used. So if we use NaCl, MnO2 and H2SO4, then also we are getting MnCl2, sodium hydrogen sulfate, and also chlorine gas is being liberated there. That is one. So these are the two methods. And the third one is action of HCl on potassium permanganate. We all know, people, we have done in the D and the F block part. KMNO4, that's the strongest oxidizing agent. Mn is in +7. So with HCl, +7 becomes MnCl2, becomes +2, and HCl is oxidized to chlorine. In fact, they have not given here. You can add one more reaction here. Please write it down. We can have a similar reaction also with potassium dichromate. Put up the balancing equation. I'll tell you what the reaction is. Write down. K2Cr2O7 plus 14HCl gives 2 moles of KCl, potassium chloride, plus 2 moles of chromium chloride, 2 moles of CrCl3, that's chromium chloride, plus 7H2O, and it gives 3 moles of chlorine plus 3 moles of Cl2. So this is also one of the methods. You can use potassium dichromate as well as KMNO4. Okay. Now coming to the part over there, we have the manufacture of chlorine. One is what is called as Deacon's process. All right. This word is what you have heard, if anybody remembers, in D block, catalyst ke use mein tha ye. I'll tell you where. It's by oxidation of hydrogen chloride gas over there in presence of CuCl2. So in the catalyst uses were there, CuCl2, D block element copper. So copper chloride, where copper is in +2, used as a catalyst for oxidation of HCl to chlorine there. That process is called Deacon's process. So in uses of catalyst, we had copper chloride. That's one. Second, we have electrolytic process. This is an important one. I want everybody please concentrate. Now it's obtained by electrolysis of brine solution. Brine is what we call as concentrated NaCl solution. Now people, aqueous NaCl, if I take, then if you all know, aqueous means in presence of water. So we'll have sodium ions, chloride ions, and water ke H plus and OH ions. We all know all ions can't be discharged. Only those ions will be discharged at the cathode whose reduction potential is higher, because at cathode there is reduction, gain of electrons. Now C for cathode, C for cations. How many cations we have? 2. Na plus, H plus. Where are sodium ions placed in the SRP series? Below hydrogen. All metals are below, if you recall. Only few metal ions are above. Copper, silver, gold, platinum, mercury. Apart from that, all metals are placed below hydrogen. So sodium has got a negative SRP as compared to hydrogen. So there will be selective discharge or preferential discharge. Sodium ions will stay in the solution. H plus ions will undergo reduction. Hydrogen gas will be liberated at the cathode. At anode, what's going to happen now, people? Anode, we have chloride ions and OH ions. Now, out of the two, oxidation potential, if you see, of OH ions is more. So, theoretically, OH ion should have oxidized and should have liberated oxygen gas. But the gas liberated at anode is not oxygen, it is chlorine gas. Why? Answer is over voltage. What is over voltage? To break the OH bond, more energy is required. So compared to the potential which is applied, if more voltage is required, that's called over voltage. So OH ions stay in the solution in spite of having higher oxidation potential. Chloride ions will get oxidized and chlorine gas is liberated. So electrolysis of aqueous NaCl, the products, hydrogen gas at the cathode, chlorine gas at the anode. And who's the electrolyte? Na plus and OH ions stay inside. So the new electrolyte is NaOH. If the same question was fused or molten NaCl, catch the word, because in fused or molten there are free ions. So sodium ions undergo reduction, sodium metal at the cathode, chlorine gas at the anode. Here it is aqueous solution, so hydrogen at cathode and chlorine at anode. Okay. Apart from this, there is one more method not specified over here. That's basically from oxides like PbO2, that's lead dioxide, or from what we call as red lead, Pb3O4. These oxides, that is PbO2 and Pb3O4, when they react with HCl, they also break down and they liberate chlorine over there with HCl. Okay, that method is there. That is an extra part. So when we are doing the Pradeep part, it will come there. Okay, so this is one. Moving next, people, what we have now, we'll talk about the properties over here. Now, in the properties, what do we know, people? Whenever chlorine, is this clear? When you try to cool an aqueous solution of chlorine, it will give yellow crystals of Cl2.8 water. Please specify this point. It is not given over here. Just write there. On cooling an aqueous solution of chlorine, it gives yellow crystals of Cl2.8 water. Yes, clear? So it basically over there nothing but gives crystals. It solidifies. That's one. And chlorine is soluble in water. We all know chlorine water, if anybody remembers, in anion analysis, when you detect the anions, chloride, bromide, iodide, we use chlorine water. So that is chlorine gas is soluble in water. So that's called chlorine water. That's one. Now come to the properties, people. It's a greenish yellow gas. It is 2 to 5 times heavier as compared to air. It is liquefied and it reacts over there where people chlorine will always get reduced because it's an electronegative atom. SRP series, fluorine, chlorine, bromine, iodine. So it's placed above. So more tendency to get, the chlorine will have more tendency to readily form its chloride over there. That's one. So it reacts with metal to form their salt. With aluminium, aluminum chloride, NaCl, ferric chloride, PCl5, S2Cl2. Please write the name of this compound. Sulfur monochloride. S2Cl2 is sulfur monochloride. It has affinity for hydrogen, so reacts with compounds containing hydrogen like with chlorine, with H2S. And what is this compound, people? C10H16. Please specify. C10H16 is turpentine oil. So it reacts with turpentine oil and it reduces it to carbon. That's the important part. So just write there. C10H16 is turpentine oil. It's a hydrocarbon. So that with chlorine reduces and removes the carbon out there. That's one. Now, people, an important reaction. With excess ammonia, all right, now chlorine gas reacts to give ammonium chloride and it liberates nitrogen gas. This is also a method of preparation what we had in group 15 with excess ammonia. But instead of ammonia excess, if you use chlorine in excess, then it forms NCl3. That's nitrogen trichloride, which is basically an explosive. People, we have NCl3 sensors. Where are these sensors? These sensors are basically in the swimming pools. Let me explain. Okay, we all know swimming pool contains chlorine water. Now chlorine, when you dissolve in water, what does it form? It forms HCl plus it forms HOCl, hypochlorous acid. This hypochlorous acid combines with the nitrogen compounds in water. Now, what are the nitrogen compounds in water? Our human body, we have proteins in our body. All right, so it reacts there. Plus sweat. Is this clear? Also some amount of urine, because you know how people are. Some people in the swimming pool also. So those nitrogen containing compounds, it reacts and it liberates nitrogen gas and it liberates the chlorine gas. Now these nitrogen gas and chlorine gas, when they are liberated, it's a highly exothermic reaction. That's why that forms NCl3, and that's why I said it could be an explosion over there. That's why we have NCl3 sensors kept in the swimming pool. So remember like this: with ammonia excess with chlorine forms ammonium chloride and nitrogen. With chlorine excess with ammonia gives you NCl3. That's nitrogen trichloride. That's an explosive. Concept of explosive clear? Due to liberation of nitrogen gas and chlorine gas, which are highly exothermic reactions. Then with cold and dilute alkali, people, these two reactions you mark very important. It forms a mixture over there. Well, look at that. Please see the slide there. NaOH with chlorine, that's cold and dilute. It forms a mixture of NaCl plus NaOCl. NaCl is sodium chloride. NaOCl, sodium oxychloride. Okay. Now here people, if you see this reaction carefully, people, this is an example of disproportionation. Simultaneous oxidation and reduction of the same species. There are 2 moles of Cl2, right? If you see. Now these 2 moles of Cl2, it breaks down. Cl2 means state is 0. In NaCl it becomes -1. So 0 to -1, that's reduction. And in NaOCl, oxygen is -2, Cl is +1. So it is 0 to +1. So 1 mole of chlorine is getting reduced, other one is getting oxidized. So same molecule getting oxidized and reduced simultaneously. That's called disproportionation. So that's an important one. That's with cold and dilute. Second we have, that's with hot and conc. Now with hot and conc also, what is happening? It's forming 2 different compounds. It's forming NaCl plus it forms NaClO3. ClO3 minus is called a chlorate ion. So this compound is sodium chlorate. So it's Na plus ClO3 minus. So sodium chlorate. Here also people, if you observe, this is also disproportionation. Cl2 0 to Cl. NaCl may -1, so 0 to -1 reduction. And NaClO3, Cl becomes +5, so 0 to +5. That's also disproportionation. So with cold and dilute, NaCl and NaOCl. With hot and conc, it is NaCl and NaClO3. And it says with dry slake lime, that is calcium hydroxide, it gives bleaching powder. Bleaching powder formula, Ca bracket OCl2, the whole twice, that we get. Okay, so these are the 2 important reactions what we have of chlorine. Next people, we have the composition of bleaching powder they have given. That is CaOCl twice with calcium chloride, calcium hydroxide and 2 moles of water. Chlorine reacts with hydrocarbons and gives substituted products. Like look at that, as well as with alkanes, alkenes. So methane plus chlorine. Remember this reaction we did in hydrocarbons, alkanes. Direct halogenation of alkanes is not a good method because it undergoes a chain reaction to form a mixture of monohalogen, dihalogen, trihalogen and tetrahalogen. So this is one of them where one H atom of hydrogen is substituted by Cl. So we get chloromethane. Second is ethene, CH2 double bond CH2. So double bond breaks, 1,1-Cl will add to it. The compound formed C2H4Cl2, that is 1,2 dichloroethane, that's the IUPAC. If the 2 Cl are attached on adjacent carbon atom, I have taught you all. What's the common name? It's called vicinal dihalides. So the common name of this compound, 1,2 dichloroethane, ethylene dichloride. Okay, so that's the addition part. Then it says chlorine water on standing loses its yellow color due to formation of, yes, I told you, chlorine, if you dissolve in water, it forms a mixture of HCl and HOCl, hypochlorous acid. And this HOCl is responsible for the bleaching nature. How? Chlorine plus water gives you HCl plus HOCl. HOCl gives HCl plus nascent oxygen. That nascent oxygen reacts with the vegetable coloring matter, or whatever is, I can say, the stain on the cloth. Is this clear? I'm just using the word vegetable matter, which is a coloring matter. That nascent oxygen converts the coloring matter into a colorless matter. That's the process of what we call as bleaching. So that's what is the idea. That's what's given there. Then next it oxidizes ferrous to ferric, matlab +2 to +3. Sulfides to sulfates. Alright, sulfide is SO3 2- over there. So SO3 2- over there, what will be the oxidation state? SO3, so -2 into 3, so -6, the charge is -2 there, so sulfur is in +4. sulfate, SO4 2 minus, it becomes +6. Then sulfur dioxide to sulfuric acid and iodine to iodic acid. So look at that. Ferrous sulfate is oxidized to ferric, and H2 and chlorine over there is reduced to HCl. Same way sodium sulfite is oxidized to sodium sulfate and chlorine is reduced to HCl. Just have a look at the slides, please. Again here, sulfur dioxide oxidized to sulfuric acid, so that's +4 to +6, and chlorine from 0 to -1. And last is iodine is oxidized from 0 to iodic acid, HiO3, where iodine is +5, so 0 to +5, and chlorine is reduced to HCl. So the powerful bleaching part, second reaction, please mark it important. Look at that, chlorine with water. Directly it's given 2HCl plus nascent oxygen. Actually the reaction is what? HCl, chlorine plus water gives you HCl plus HOCl. HOCl again breaks down to give HCl plus nascent oxygen. So directly it's written in one step. Okay, and that coloring substance reacts to become a colorless substance. That's the process of bleaching. Then the uses, people, what we have now, observe this. It's for bleaching wood pulp, extraction of gold and platinum over there, manufacture of dyes and all, and also drugs and compounds like carbon tetrachloride, chloroform, CHCl3, DDT, people, this is an insecticide. First D stands for dichloro, second D stands for diphenyl, and the T stands for trichloromethane. Full name: dichloro, diphenyl, trichloromethane. Dichloro, diphenyl, trichloromethane. That's the part. We'll be doing this in halogen derivative. Iska preparation hai. And some poisonous gases. People observe this now. One is phosgene, COCl2. Okay. Phosgene, yaad hai kisi ko? Surface chemistry. If a chloroform bottle is kept open, then what's going to happen? Sunlight will pass through, chloroform gets oxidized to phosgene gas. So to prevent the formation of phosgene, we add 2% ethanol, which is nothing but a inhibitor, which will prevent the formation of phosgene. And if phosgene is formed, it converts it to a harmless gas called diethyl carbonate. So that's phosgene. How is it formed? Carbon monoxide plus chlorine in presence of UV light gives you phosgene. Second one, people, tear gas, CCl3NO2. Come on, what will be the IUPAC name of this compound? Anybody? Trichloro nitromethane. I repeat, trichloro nitromethane. Okay, so this is when chloroform is oxidized. All right, or chloroform over there, when it is oxidized over there, chloroform reacts with nitric acid, HNO3, then it forms nothing but tear gas. And second is mustard gas. Mustard gas is basically used in warfare over there. Look at the compound. How is this compound formed? When ethene, all right, combine 2 moles of ethene combines with S2Cl2, we just saw on the previous page, sulfur monochloride. Then the bonds will be 2 ethylene moles, so CH2CH2 in between one sulfur, and then ClCl on the side. So sulfur in between, CH2CH2Cl on one side, right side also CH2CH2Cl, CH2CH2Cl, and plus one extra sulfur is given out as a byproduct. So the reaction, 2 moles of ethene, CH2 double bond CH2 plus S2Cl2, that sulfur monochloride, gives this compound CH2CH2Cl, बीच में S and a mirror image, CH2CH2Cl plus sulfur. That's mustard gas. Okay, that's one. Second, we have, people, here chlorine reacting with hot and concentrated, and it says is disproportionation. Yes, I discussed with you. Yes, it is, because with hot and conc, what will it form, people? NaCl and sodium perchlorate. That is nothing but sodium chlorate, not perchlorate. Perchlorate is ClO4. This is NaClO3, that is sodium chlorate. So chlorine, which is 0, becomes -1, and the other one becomes +5. Okay, so that's the part given over there. So that's what disproportionation. So remember the definition. What is disproportionation? Simultaneous oxidation and reduction of the same species. Then the reason for bleaching, people, bleaching we discussed, it's because of nascent oxygen, what it gives. So chlorine plus water, what I discussed, that reaction. So because of that nascent oxygen, it's the bleaching action is there. And 2 poisonous gases which are prepared. Now there are 3 of them over here. One, we have phosgene, then we have tear gas, gives tears in the eyes, used by the police. also called as, I gave you the IUPAC, trichloronitromethane and mustard gas. All right, so that's one. Then next we have people the second compound, hydrogen chloride, that is HCl gas, what we all know. All right, now this part in water we also call it as muriatic acid, if you people have heard about it. Now how is this formed, people? In the laboratory, it's by heating sodium chloride with concentrated sulfuric acid, where it forms NaHSO4, that is sodium hydrogen sulfate, which again reacts with NaCl to give over there sodium sulfate and HCl. Please write one line here, very important. This method is also called salt cake method. Catch the word, salt cake method. Please specify here. Why? Because the NaHSO4 formed, all right, it forms an insoluble salt coating. The sodium hydrogen sulfate form will have a insoluble salt coating. That's why it's also called salt cake method. That's one. And HCl is dried and passed through sulfuric acid. Colorless smelling gas, it is liquefied. HCl in water, we all know it's a monobasic acid, so gives 1 H plus ions. So people, the reaction HCl with water, it forms H3O plus. People, drawback of Arrhenius theory, free H plus ions don't exist in water, they exist as hydronium ion. And look at the K, 10 raised to 7, very, very high. Remember the logic of K, right? Larger the K, stronger the acid. So 10 raised to 7, so very strong acid. It's hydrochloric acid. Then it reacts with ammonia. Yes, we have discussed this. This was in the MCQs, if you remember, of group 15. Rod dipped in HCl got near a jar of ammonia will give white dense fumes of ammonium chloride. Then next is people about aqua regia. What is aqua regia? 3 parts HCl, 1 part HNO3, used to dissolve noble metals like gold, silver and platinum. So that is the use there. 3 parts of HCl and 1 part of HNO3. Aqua regia, that is, look at that, gold with H plus ions and nitrate and chloride forms AuCl4 minus. People, coordinated complex. Chlorine is the negatively charged ligand. AlCl4 minus. IUPAC bolo chalo. Anybody? Tetrachlorido. And it's an anion. So the name of the metal will end with 8. Tetrachlorido orate. And it has a charge of -1. So gold oxidation state, Roman number 3. I repeat the name. Tetrachlorido orate in a bracket, Roman number 3. Okay, because gold is called orb. Second one, platinum combines there with nitrate and chloride to form PtCl6 2 minus. How do we name it now? Hexachlorido, Pt, platinate. Now Cl is -1 into 6, so -6. Outside the charge is -4, so platinum is oxygen status +4. So the name hexachlorido platinate, Roman number 4 in a bracket. So what you write in a bracket is its oxidation state. That's called the parenthesis. We'll be learning about this in coordination compounds. So these are the complex it forms. Acha, one thing, people get confused. Aqua regia to ho gaya. 3 parts HCl and 1 part HNO3. What's nitrating mixture in organic? Remember, benzene reacts with nitrating mixture to give you nitrobenzene. क्या था nitrating mixture, किसी को याद है? Think about it. Nitrating mixture. It's a mixture of concentrated nitric acid and concentrated sulfuric acid in the ratio of 1:2. 1 part of conc HNO3, 2 parts of conc H2SO4. What is the function of this nitrating mixture? Helps to generate the electrophile NO2 plus. That's nitronium ion. ये याद रखो, important point है. Okay, that's nitrating mixture. So confused नहीं होना. Aqua regia, 3 parts HCl, 1 part HNO3. Nitrating mixture, 1 part HNO3, 2 parts conc H2SO4, helps to generate the electrophile NO2 plus. Then people, HCl will decompose salts of weak acids like sodium carbonate, strong acid, weak base. So it forms NaCl, water and CO2. Sodium hydrogen carbonate, what we also call as baking soda, that it breaks down, and sodium sulfate also gives NaCl with water and SO2. Then people used in the manufacture of chlorine, ammonium chloride and glucose from corn starch. People, this will be doing in biomolecules. Starch is nothing but a polysaccharide. It is a homopolysaccharide of glucose, meaning when starch is broken down, it gives only molecules of glucose. So that's what the part over there from starch. Then for extracting glue from bones and purifying bone black, I have discussed with this you in adsorption. Bone black is when the bones of the animals are taken and they are heated with limited supply of oxygen. Then they form black powder bone that's called as bone black or bone charcoal. मेन फंक्शन किसी को याद हो मैंने बताया था शुगर के जो white crystals है how do we get the white crystals when this bone charcoal के साथ when they are mixed adsorption function of bone black is to adsorb color. So for the extraction part of this we use HCl. Now look at the reaction there. HCl with finely powdered iron people. It forms ferrous chloride and not ferric. मतलब when you react with Fe, why it forms ferrous and not ferric over there? Because hydrogen gas is formed. Hydrogen will prevent the formation of ferric there. Okay, so Fe is oxidized only to ferrous. That's one. Now, next comes people, like how we did oxides of nitrogen, oxoacids of phosphorus, oxoacids of sulfur, now oxoacids of halogens. Oxoacids, oxygen containing acids. Now first of all, we have discussed this last lecture, because of high electronegativity, fluorine, we all know, fluorine is a super halogen. Very small size, no vacant d orbital, low bond dissociation enthalpy, high hydration enthalpy. That makes fluorine a super halogen with only one oxidation state, -1 only. So there's only one oxy acid formed, HOF. That's called hypofluorous acid. If you remember, I discussed last time, F is -1, H is +1, oxygen ka oxidation state is 0. Now, people look at this table here. So fluorine will be only one, hypofluorous. Then chlorine forms all the four. That's basically +1, +3, +5 and +7 oxidation state. That is ground state, it's NS2NP5. Then the first excited state, one lone pair breaks. Second excited state, second. And the third excited state, the third lone pair will break and go to the vacant d orbital. So that's why we have all. With bromine, it forms 3 only, hypobromous, bromic and perbromic. And iodine also forms only 3 over there. Now we have to know these structures. I have a very simple way to remember them. HOCl, matlab there's a OH bond bonded to Cl, because Lewis structure wise we can frame the structure how it is. So that's called hypochlorous acid. I've discussed hypo means lowest oxidation state, Cl is +1. So the structure लिखना हो तो कैसे लिखोगे? Please look at me everybody. Cl, फिर left में लिखो O and then H. So develop the habit of writing it like this, okay? Or you can write like this, better way, चलो. H dash O dash Cl, okay? ये हो गया. Nothing but first one, hypochlorous acid. दूसरा, chlorous acid, HClO2. अभी oxidation state करो, HClO2. O is -2 into 2, -4. So Cl is +3. अब कैसे लिखोगे? H dash O dash Cl double bond O. पहला क्या था? H dash O dash Cl. दूसरा वाला प्लीज राइट इन अ बुक, इजी हो जाएगा. H dash O dash Cl double bond O. मतलब chlorine forms 3 bonds. Okay, so that's what we call as chlorous acid. Cl is +3. तीसरा, chloric acid. Now chloric, HClO3. Okay, so Cl is +5. कैसे लिखोगे? H single bond O, single bond Cl. Cl पे double bond O और एक double bond O. मतलब Cl will have 2 double bond O. So first HOCl, just no double bond. H dash O dash Cl. HClO2. H dash O dash Cl double bond O. HClO3. H dash O dash Cl, a double bond O and again a double bond O. So 2 double bond O with Cl. And last, HClO4, perchloric acid, where Cl has the highest state, +7. कैसे लिखोगे? H dash O dash Cl. And Cl पे there'll be 3 double bond O. Okay, so HOCl, no double bond O. HClO2, 1 ClO double bond. HClO3, 2 ClO double bond. And HClO4, there'll be 3 ClO double bonds. Look at the structure there. So hypochlorous, nothing. Chlorous, 1 ClO double bond, what I was talking. HCl, chloric acid, HClO3, 2 double bonds. And HClO4, there will be 3 double bonds. What are these ClO double bonds called? There's one name to it. These are called unhydrogenated oxygen atom, meaning oxygen atom which do not have any hydrogen attached to it. So more the number of unhydrogenated oxygen atoms attached, the ClO bond will be a strongly covalent bond because Cl and O both are electronegative. So when dissolved in water, which bond will readily break? The OH bond will break. So more the number of unhydrogenated oxygen, that's in HClO4 maximum, there are 3 ClO bonds, double bond O. So then the pull of these, the minus I effect, negative inductivity is so strong that they pull the OH ka electrons toward itself. So the OH bond breaks and releases H plus ions. Faster the H plus ions given, stronger the acid. Hence perchloric acid is a strong acid. In ionic we discussed, it's one of the acids which has a negative P of H. It's a corrosive acid. Clear? So these are the oxy acid of chlorine. Hypochlorous, chlorous, chloric, perchloric. Hypochlorous, chlorous, chloric, perchloric. Hypochlorous, HOCl. Hypochlorous, chlorous acid, HClO2. HOCl, double bond O. Chloric acid, HClO3. HOCl, Cl पे double bond हो, वापस double bond हो. So 2 ClO double bonds. And last perchloric, HClO4. H, single bond O, single bond Cl, and 3 double bond O on that Cl. Alright, that's one. Then comes the last part, people. What we have with this group 17 is over. Interhalogen compounds. The word is the answer, interhalogen. When two halogen atoms combine, then the compounds are called interhalogen compounds. And this, they form a variety. We discussed in the physical properties also. That is, they form the compound XX dash, XX dash 1 with XS5 and XS7 over there. So plus 1, plus 3, plus 5 and plus 7, where we say the X, capital X, is for the bigger halogen and X dash is generally for the smaller halogen. Now the smallest halogen is F, we all know. Okay, so that's the part over there. So where iodine, where what it says, with the smaller halogen, as the ratio between the radii of X and X dash increases, the number of atoms per molecule will also increase. So I and F, if I take, iodine will have the largest size, fluorine the smallest, so the radii difference will be more. So maximum atoms can be accommodated. We have the example IF7, iodine, nothing but heptafluoride, which was sp3d3 hybridized pentagonal bipyramidal geometry. That's one. Okay. Then, people, we have some of the preparations here of these interhalogen compounds. What it says, one is chlorine and fluorine in equal amounts. If you take, we get ClF, that's called chlorine monofluoride. If fluorine is in excess, we get ClF3, that's called chlorine trifluoride. किसी को याद आ रहा है? ClF3. ClF3 bent T-shaped VSEPR. Alright. This compound is distorted sp3 dehybridized T-shaped geometry where we have two lone pairs. And where are the two lone pairs? At the equatorial position. So the axial bonds will bend little bit. So it's in the form of a T-shaped structure. Then iodine and chlorine, ICl, that's iodine monochloride. With chlorine excess, it forms ICl3, that's iodine trichloride. Then bromine, when diluted with water, it forms BRF3, that's bromine trifluoride. And with excess fluorine, it forms BRF5, bromine pentafluoride. Ye bhi tha. Two compounds were there in VSEPR. One is ClF3, I told you, distorted sp3d, bent T-shaped, two lone pairs at the equatorial position. So the axial bonds are bended in the form of a T there. BRF5, if anybody remembers, bromine pentafluoride, distorted sp3d2 hybridized. So this was an octahedral regular geometry, but it is distorted. And what is the shape? Square pyramidal, meaning you have Br at the center, 4 fluorine at the 4 corners of the plane, and up and down, that's the axial ones. There's only one fluorine on the top, down there is a lone pair. So you have 4 at the 4 corners of the square and 1 fluorine up. So the shape looks nothing but square pyramidal geometry. Alright, that's the two, what we have with VSEPR part. Now, people, certain compounds over here, what are they? They are some colorless gases. Which may important as some of them, I'll discuss this. ICl, that's a ruby red solid, which is alpha form of it. That's the allotrope. So that's this one. And beta red solid, that's a brown form. Then one is a black solid there, that's IBr. Now these are important. Look at that. ClF3, that's bent T-shaped. For your understanding to recall, I've got the diagrams. Look at this. These two fluorine, what I'm highlighting, please have a look at it. These are the axial positions and these are the two at the equatorial. Is this clear? So because of that, it forms a bent T-shaped distorted sp3d. Then IF3, the yellow part. All right, here they have given certain things. People as A, B, and all that. A means it's very unstable, like IF. B stands for the pure solid is known at room temperature, that is BrCl gas. C is also written, that is ICl3, that's an orange solid, where C stands for it dimerizes as a chlorine bridge dimer, I2Cl6. Like how we did know, 2NO2 combines to form N2O4. Same way, 2ICl3 will form I2Cl6. Then IF5 people, similar to BrF5, similar type. That's a square pyramidal geometry, what I told, distorted sp3d2. People look at this. That's this diagram. Br in the center, 4 fluorine on the 4 corners of the plane and 1 fluorine up and down is the lone pair. Okay, so it's a square pyramidal shape. And IF7, that's the regular geometry, no distorted. That's pentagonal bipyramidal, which is sp3d3 hybridized. I have given the shape over here. Well, look at that. We have the 2 axial up and down is a pentagon if you join them. So that's why pentagonal bipyramidal geometry. Okay, this is one. Then next we have, yes people, now these are covalent bonds because 2 halogen atoms, they are electronegative, so it will be covalent bonds, and they are diamagnetic. Matlab all electrons are paired and they will be repelled in a weak magnetic field. All right. Now here people will say in these compounds, what is the main part over there? These XX bonds of the what I can call as interhalogen, they are weak bonds as compared to the pure halogen bonds. Matlab if I have to compare ClF bond and a chlorine-chlorine bond, chlorine-chlorine, Cl-Cl bond will be stronger than ClF. Why? Between the 2 chlorine atoms, there is no difference in electronegativity, but in ClF, there will be a slight difference. So because of that difference in En, partial charges are created, which leads to polarization. All right, so that's why remember these bonds are weak bonds. Physical properties are, yes, they are next to the halogen part, but their melting points and boiling points are higher. That's, I just said the answer, because they get polarized. Charges. So the charges are developed, you have to supply more energy. So that's why their melting and boiling points are higher. In general, interhalogen compounds are more reactive than halogen, except for fluorine. The XX bond in interhalogen is weaker, very important point people, than XX bond in halogen except fluorine-fluorine. I told you the reason there. FF bond is weaker. Why? We discussed, no? Bond dissociation enthalpy of FF bond is low. Why? Because of the interelectronic repulsions. And why interhalogen bonds are weaker? Because of polarization, difference in En. Pure halogen atoms will have no difference in En. That's why they are more stronger as compared to the interhalogen bonds. All right. They undergo hydrolysis and they form their respective hypohalides. Halides, matlab, I just now discussed, no? Hypochlorous, chlorous, chloric, and perchloric acid. So that's why the salts what it says. So halate and perhalate. That's the anions what are formed there. So interhalogen with water will form the HX acid and it gives its respective oxy compound. Then on the basis of VSCPR, they have explained this part. XX3, matlab ClF3, bent T-shaped, distorted sp3d. XS5, matlab like BrF5, that's a square pyramidal, that's distorted sp3d2 hybridized. And IF7, which is regular, that's a pentagonal bipyramidal geometry. Now, the last part, people, explanation is whole of VSCPR, what would in nature of chemical bond. Look at that, BrF3, these two F bonds, what you see in the diagram, they are basically the axial bonds. And the lone pairs, what I'm highlighting here, they are the equatorial bonds. So repulsion, lone pair repulsion, greater than lone pair repulsion, greater than bond pair repulsion. So the bond angle is closer there. So if you see ClF3, that's where it says the angle is somewhere around 87 degrees 29 minutes. So basically we can say 87.5 degrees. That's the bond angle what it comes to. That's the part. So it's a bent T shape. The whole explanation part is there. Trigonal bipyramidal. And the lone pairs will occupy the equatorial positions. Clear? Last comes people uses. They can be used in non-aqueous solvents and they are used as fluorinating agents like ClF3, BrF3. They are used for production of very important use. UF6 is uranium hexafluoride. That's for the enrichment of the U35 isotope, which is used as a fuel in nuclear reactors to carry out what we call as the nuclear fission reaction. So uranium with ClF3 gives you uranium hexafluoride and ClF. Okay, we can put some more uses. I wanted to pen it down, write down somewhere, people, some of the uses over there what we have. Okay, more uses you can say. Okay, these are also used in 1 minute. I will give you a list of the uses there. Please pen it down. I have written it down somewhere. 1 minute. I'll give it to you. Yeah, write down. Into halogen compounds, just specify. ICl, iodine monochloride. ICl is used for the estimation of iodine number. We'll be doing this in biomolecules. ICl, iodine monochloride, is used in the estimation of iodine number of oils and fats. This is mainly to detect over there the presence of unsaturation. For that is one. And second one, you can write there, ClF3 and BrF3 are used as ClF3 and BrF3 are used as oxidizers in propellants. Propellants is basically the what I can call as propellant is something when a rocket fuel is to be ignited over there. So you require the propellants which will help in the initial combustion part over there. So there these compounds are used. So these are the intelligent compounds. With this, people, group 17 is over. Last one question to do. That's it. Then next class we'll discuss group 18. It says, why is ICl more reactive than iodine itself? I discussed. Intelligent compounds, the ICl bond is weaker because of polarization, difference in En. Pure iodine will have no difference in En. That's why ICl will be more reactive than iodine itself. Okay. All right, people. That's it for the day. Thank you.